Greetings, everyone. These notes are going to run through quickly just kind of what we talked about Wednesday and Thursday on what we refer to as kinematic equations and how we can use them to start predict how objects move. Now, I do apologize. When I wrote these notes, I did them in a nice, lovely lilac pen, but as you can clearly see, lilac does not scan over super well. So I've kind of gone through and I've rewritten some of the equations that are kind of difficult to see. But basically, kinematics is a way that we can solve problems that relate to motion. All right. Now, I started these notes in class by asking you to kind of brainstorm a few different physical quantities that we can measure for motion. I'm not going to worry about that because this is the review notes. So, some things we can measure just to remind ourselves about motion. We can measure things like velocity, position, displacement, which is the change in position, acceleration. All right. All of those things are related, even time, all have some role to play when we talk about motion. All right. Now, what we're going to do is we're going to create 4 equations. And if you want to go, I mean, you can see them, see how I do them later. But if you want me to kind of walk through how to make the equations, you're welcome to come during office hours. It's not really that important. Really, what does matter is that what we're doing is we're taking some physical meaning, taking some of these graphs, in this case, a velocity time graph, and we're basically just applying physical meaning to that graph. All right, so the stuff you do in math class can seem kind of dull and boring, and why do we ever use it? Well, the reason we use it is because we apply it to physics. All right. Now, there are 4 equations in kinematics that allow us to kind of calculate different pieces about the motion of an object. And we're going to talk about what these symbols all mean, but basically, the 4 equations look like this. The first equation says that the final velocity of an object is equal to the initial velocity of the object plus the acceleration of that object times how long it's been moving. All right? That's the first kinematic equation. And we're going to practice using these in the second half of the notes and in further notes in the future. So for now, you don't just kind of look at that equation, write it down, and we'll talk about how to use it in a sec. Second equation says that the displacement of an object is equal to 1/2 times the starting velocity or the initial velocity of the object plus the final velocity of the object multiplied by the time it's been moving for. Now, initial velocity and final velocity are basically, that would be when I start looking at it and when I stop looking at the object. All right, so that's just kind of what those two mean. Next, the third equation, all right, says that the displacement of an object is equal to the initial velocity of the object multiplied by time plus 1/2 times the acceleration of the object times time squared. All right, now these equations allow us to solve for different pieces of motion. And if you kind of look at it, you'll notice each one of them has a common theme in that they all have 4 variables. But the types of variables change. In fact, each equation is missing a variable that one of the other ones might have. All right, and that's important because we're going to find out that there are different situations we use each equation. All right, and the fourth and final equation, the last one we're going to write down, says that the displacement of an object is equal to the final velocity squared minus the initial velocity squared divided by 2a. All right. Now, again, I am happy to explain in office hours if you want to come in and ask how we did this. This is, again, kind of the shortened version of just how of the equations. I'm not super worried about you understanding how we build the equations because they're not really particularly relevant to class right now. I just want you to understand that we have 4 different equations that allow us to map out the motion of an object. So I'm going to take a second. I'm just going to stop for a moment to make sure you have a chance to write down these 4 equations. All right, so once you've written these 4 equations down, we need a way to organize our information so that we can actually use them. All right, because equations are nice, but we got to know how to actually use them to actually mean anything. So what we do is we start by drawing something that we're going to refer to as a kinematics chart. Now in forces, we always start a problem by drawing an FBD. Well, in kinematics, you have the same idea. You're always going to start a kinematics problem by doing this. You're going to draw a kinematics chart to organize your thoughts. All right. Now, kinematics is just a fancy way of saying motion. And in motion, there are 5 pieces of information that we want to know about an object that can help us figure out more things about that object's motion. All right. So those 5 pieces of information, when you draw the chart, usually I just draw a T-chart. On your Google Doc, probably want to just make a 2x5 table, so 2 across 5 down. But what you're going to do is on the left side, you're going to put the 5 kinematic variables. All right? And that is VI, initial velocity, how fast I'm going when I start looking at this object. VF, final velocity, how fast I'm going when I stop looking at the object. A, acceleration, pretty self-explanatory. T, time, that's just basically the time it's been traveling. And delta X, which is the displacement. All right. Now, you're going to see in little pieces where it's going to seem confusing because you're going to say, well, displacement and distance, because sometimes you'll see displacement, sometimes you'll see distance pop up. For these questions, we only talk about something going in one direction right now. So usually displacement and distance can actually be used interchangeably because if you only go in one direction, displacement and distance are the same thing. All right. Now, one thing that's really important, and I want you to include on your notes, I wrote it right here, but I want you to put it again, is that you must know 3 pieces of information, 3 of these variables, before you can find the other ones. All right? And that is very important. In order to use any of the equations, you must know 3 variables. All right? Once you know 3 variables, you can solve for the other 2 easily. But you must figure out at least 3 of the variables before you can do anything in kinematics. All right. Now, best way to use this is to practice with it. So let's look at our practice question. So the car starts from rest and begins speeding up at 6 meters per second squared, and it speeds up for 5 seconds. And it wants to know how far did it go. Well, we start by filling out our kinematic chart. So we start by drawing this chart. That's the very first thing we always do. All right, and then we put on the right side, we just put the 5 variables. And again, it doesn't matter what order you put them in. Not going to really affect your question at all. And then we ask ourselves, all right, do we know these things? So let's start with the first one, initial velocity. Looking at the question, the initial velocity is 0 because it says it starts from rest. All right, and again, we're going to start getting used to this idea. We're getting used to these physics context clues in a way. We're getting used to reading the question, looking for things it tells us about physics. In this case, from rest, VI is 0. I don't know VF yet. It doesn't tell me anything about the final velocity, so I got to leave that blank. A, however, I do know, because it says it begins speeding up at 6 meters per second squared. So I know the acceleration is going to be 6 meters per second squared. And again, all I'm literally doing is I'm just reading the question and writing down pieces of information that the question gives me that are related to the 5 kinematic variables. All right? Next, time. It asks how much time is this moving for? Well, congratulations, it tells us it speeds up for 5 seconds. So I know that the time is 5 seconds. Which means now I have everything I need to solve for the stuff I don't know. I don't know delta x, but what's nice is it says, how far did it go? It wants us to find delta x. All right? So this is where it comes down to how we pick the formula. When you pick a kinematic equation to solve with, you need to look at the 4 variables that you either know or want to find. And in this case, I know VI, I know A, I know T, and I want to find delta x. So you basically want to look for the equation that doesn't involve the final velocity. All right, because remember, each equation has only 4 variables in it. Looking at those equations, you actually find that the third equation we wrote down is the one that's going to work for this because it has all 4 of those things. It has delta x that we're looking for, VI, which we know, T, which we know, and A, which we know. So once you do that, you just go in and you plug in the values. So you can kind of see it faintly in here. I start with delta x equals, and I replace VI with 0, because that's the starting velocity. T with 5 seconds, because that's the time. 1/2 with 6 meters per second squared, because that's the acceleration. So 1/2 times the acceleration, which is 6, times the time again. Remember, the time is squared. Put that in parentheses to make it a little easier. T squared. So plug in, calculate it. You get the delta x is 75 meters. 75. Not 7.5, 75. All right? And again, this is something now that in this class, I expect you to be able to plug in numbers and solve for them. All right, and I don't mean to sound condescending or demeaning, and not at all. If you're not quite sure, you're not certain, please come talk to me about it. That's why I'm saying this. You need to come work through this until we can solve it together, because these are skills you need to have by the time we get to the quiz. All right, but right there, all you did was you looked at your chart, you solved using the formula, plug stuff in, boom, you got the answer. All right. Now, last question. It says it wants us to also figure out how fast we're going after 5 seconds, which means we want to find VF. All right. Well, again, you just keep going. You ask yourself, which equation should we use? And in fact, if you know 4 things in the chart, you pretty much can use just about any equation to find what you're looking for. But in this case, we already have an equation that's laid out very nicely for VF. the first one, so VF equals VI plus AT. Plug in what we know. All right. We know VI is 0. We know A is 6 meters per second squared. We know time is 5 seconds. Go through and calculate it, and you get that the final velocity that this object will be moving after 5 seconds is 30 meters per second. All right. So again, this is just a quick little review of the kinematic formulas and how to use them. They're going to pop up a lot the next couple weeks. So if you're kind of like not quite sure after watching this video, do not worry. We're going to practice them a bunch. If you have any questions, please don't hesitate to reach out. Otherwise, have a great rest of the day.